Welcome everyone to the latest Reimagine Mobility podcast series. I'm here with Paul Gray from Cohda Wireless. Paul, thanks so much for your time and joining us from Australia nonetheless. Appreciate it. Tell us a little bit about your role, how you started with Cohda Wireless, where things are right now, and then let's jump in after that and really develop together the idea of how can we reimagine mobility.
Yeah, certainly. Thanks for having me. So I'm CEO here at Cohda Wireless. I've been doing that for quite a few years now. I've been with Cohda almost from the beginning. So Cohda was founded back in 2004. I joined in 2006 as Vice President of Engineering. So I did that for about 5 years, and working on our products, being developed at that stage before moving into the CEO role.
Very good. Let's talk about a little bit about V2V, V2X. I think you guys, at least when I still remember a few years ago, were very focused on DSRC. DSRC, I think in some countries still the go-to for V2V and V2X. Other places they're now talking about cellular V2X. Give us a little bit of a background what you have seen since you started at Cohda, this whole evolvement of DSRC, maybe not DSRC, are we doing it, are we not doing it? Give us a little picture of that, where things have come, and then also, at the end, where do you see it going over the next few years?
Yeah, certainly. So, as you note, V2X, or, this vehicle-to-vehicle, vehicle-to-infrastructure, or vehicle-to-everything communications, really started out based around IEEE 802.11p technology, or, DSRC. So it was based upon Wi-Fi standards, customized, designed, specifically for short-range communications in the automotive sector. And that's the way it stood for a number of years. We were involved in trials right from the early days. So things like the SIMTD trials in Germany, the safety pilot trials in the US, they were all DSRC based. And then, I guess, trying to think exactly when. I suppose there's pretty talk about it maybe as 10 years ago, this cellular V2X, which was an alternate technology based on the 3GPP standards, also 4G, now 5G standards. So cellular V2X is still a peer-to-peer, point-to-point communications system operating, in the same bands as DSRC, but based around the cellular standards. And that's been on the rise for the last few years and slowly growing traction. So much so that now it's been selected as the preferred choice by the FCC for operations in the US. There's a notice of proposed rulemaking out from the FCC, but it hasn't become a rule yet. That's a little ways away. But in the meantime, there is the FCC has approved waivers to allow organisations such as ourselves or departments of transport or so on to deploy the cellular V2X technology. Meanwhile, in other jurisdictions, we see China, for example, has always been cellular V2X. They never really considered it any alternative, so that's the dominant standard there. Whereas in Europe, there's a lot of DSRC deployments, and there's a lot of ongoing debate about DSRC versus CV2X, but it's for the moment, it certainly seems like DSRC has got a stronger foothold in Europe than it has, say in the US. Yeah, so where it goes from here, I think it really feels like things are settling down finally, and things are moving ahead. So I think we're going to see. In the US, it's going to be cellular V2X. Probably in Europe is DSRC. From the automotive sector, it's a little bit, I guess, almost agnostic in that there are now chips available which can support either communications standard, just be reconfigured to be cellular V2X or DSRC. But so it can be really, they can at the factory you can fit one unit which can do either. And depending where the vehicle gets deployed, it can switch into either mode.
Interesting. So when we then talk about Cohda Wireless, you guys working on the chip, I assume you're still working on the software piece as well. How much are you guys doing, and how much then are you passing on maybe to a traditional tier one manufacturer like a Bosch, a Continental, that then integrates your chipset, your software into a control module or into a larger system that goes into the vehicle. Share a little bit about what you have done and maybe how that has changed, or same thing, how that may change as you guys progressing and starting now really go into hopefully mass production soon too for some of those applications.
Yeah, certainly. So, it is true that Cohda is a tier 2 supplier, so we are supplying to the tier 1s. In the early days, we were more focused on developing chips, and so we had a strong partnership with NXP Semiconductors, where we co-developed a DSRC chip for this market, where it was a software-defined radio. NXP did the automotive grade silicon, and we provided the software into that. Over time, we've moved. Our focus has been more on the higher layer stacks and applications. So now our dominant work is in the network layer, facilities layer, and also the applications, both for day one applications, for manually driven vehicles as well, going all the way to connected autonomous vehicles. So that's where we sit today, and we have a few major projects like that. So in terms of mass production, we're actually today providing the network and facilities layer and applications into the VW Golf 8 and some other VW vehicles in Europe. In that instance, LG Electronics is the tier 1, so that's in production now. Another major project we're involved in is we have a partnership with Autotalks. So they're an Israeli chip maker who make a chip that can operate in either DSRC or cellular V2X mode. They're working on their third generation system on a chip, and in this chip there's the network layer and facilities layer are actually going to be integrated into the chip, as well as potentially even simple applications. And so we're working closely with Autotalks at the moment, developing that third generation chip, where we'll be doing software that will be, rather than supplied to a tier 1 as we do today, the tier 1 will just buy a chip that already has all the software stacks integrated.
Oh, very interesting. Maybe shift a little bit from the topics. Over the years, I've always heard and dealt with two types of camps, let's say, of people, right? The one camp says, oh my gosh, we need V2V, we need V2X, it's critical, be it DSRC or be it cellular V2X, it doesn't really matter, but we need it to truly go autonomous. Anything above level 3, we need this. And then I heard the other camp always say, yeah, it's an additional safety, it's an additional way of assuring autonomous, but we don't really need it. Look at all those sensors that we have. Now we have LiDAR pretty much, going into for sure level 4, level 5 vehicles. We've come so far with vision systems, with radar, etc. What is your perspective? I assume you would probably say, no, you need it, but what is sort of your perspective to the ones that say they don't need it, and maybe to the ones that say it's absolutely 100% critical? Where do you see it?
I think it's really, it's in the early days, obviously, when, if there's nobody else for you to talk to and you're trying to build an autonomous vehicle, naturally you're going to focus in on a sensor suite that is self-contained. It's solely in your vehicle, and because that's all you can depend on. But over time, as there's more connected vehicles, it really becomes a no-brainer that you're going to have these vehicles connected. You're still going to have your LiDARs and radars and so on, but there's just so much more you can do if you actually connect those vehicles. The simple example is obviously with things like cooperative perception. So cameras, radar, LiDAR, they're all line of sight. You can't see around the corner. So imagine the scenario, you're coming to a blind corner. There's a child on a bicycle just around the corner. None of your sensors can detect that scenario, but there could be another vehicle passing on the other side of the road that has clear view of the child on the bicycle. Well, they can perceive that and then share that information with you. So it comes down to the real value of connecting things. It's the network effect, where essentially says that the value of a network grows with the square of the number of connections. So obviously, if you're the first, it goes back. The whole theory of the network effect goes back even to telephone networks, where it's like if you're the first person in your village with a telephone, well, what value is it to you? But when there's 10 other people in your village who have a telephone, then then you suddenly you've got 100 possible connections you can make, and the same goes for vehicles. When there's 100 cars in your village who are connected, then there's suddenly 10,000 connections you make, and by the time you grow to 1,000 vehicles, there's now 1 million possible connections you can make. So it's that value just grows so rapidly. It's like in the early days where we are now, it's hard to justify having it in the vehicle. But if everybody else is on the road has got it, it's a no-brainer.
Yeah, very good point. When I personally got involved with DSRC, it was back, I think it was 08, 09 timeframe, 2010 maybe, right? And the big focus then, at least in the US, from the government really pushing it, was vehicle-to-infrastructure. So we heavily were involved with signal phase and timing, talking to a traffic light for giving you that type of capability of how do you slow down, you constantly have a green wave of driving, all of that stuff. And then I felt like maybe 3-4 years later, it really shifted and the focus went away from vehicle to infrastructure, much more to vehicle. As you just explained how important it is to see around corners for the increased safety and for the communication and the networking effect and all this, great point. What is more important? Is vehicle to infrastructure more important? Is vehicle to vehicle more important? Or have we just chosen one to roll out before the other, or is both going in parallel, or how is this really all going on right now?
Well, I think the benefits of V2X is twofold. It's about safety, and it's also about mobility or reducing congestion. And so the vehicle-to-vehicle stuff can largely be grouped together under in the safety bucket, and say, right, any sort of vehicle-to-vehicle interactions can improve safety. But those vehicle-to-infrastructure connections are more about having the vehicles more tightly integrated with the traffic management systems. And so that can really have a boon in terms of reducing congestion and having traffic flow more smoothly and so on. And so but it still all suffers a little bit from the chicken or the egg. It's like, well, if the vehicles aren't connected, then why put the infrastructure in? And if the infrastructure isn't there, why connect the vehicles? But we are starting to see those vehicle-to-infrastructure connections as being one of the primary use cases which is driving the rollout of infrastructure. And that's usually surrounding closed or dedicated fleets. So two of the big applications we see are emergency vehicle preemption, because often the Department of Transport or the state has control of both the traffic lights and the emergency vehicles, and so you can have that advantage of keeping those vehicles moving. And the other one is transit signal priority. So now you're actually giving priority to buses and light rail and so on at intersections where the state can see the advantage of having both connected, and suddenly that's the positive business case for deploying the infrastructure.
Very good. If we switch topics maybe slightly again a little bit, we've talked before when we ask, is it cellular V2X, is it DSRC based V2X, and you kind of explained that very well. The next question now I have, and very curious what you see, which country or which region is most progressive when it comes to pushing DSRC? Is it China? Is it Greater Asia? Is it the US? Is it Europe? Is it specific countries in Europe? What do you see, and why is that, I guess, too, then?
Yeah, I would say at the moment they're largely, broadly neck and neck. I mean, I think at the moment Europe is a little bit more advanced, simply because there is more coordination between on the infrastructure side and the vehicle side. So you've got organisations like C-Roads in Europe who are deploying the infrastructure onto roads, and they've got quite a large number of roadside units now deployed in Europe around C-Roads initiatives. And also C-Roads works quite closely with the car-to-car communications consortium, which is the automotive side. So we're seeing now, obviously we have VW vehicles on the road in Europe. So now today more than 1 million connected VW vehicles are out on the road. So it's sort of like, I think Europe is a nose ahead, but obviously in the US there's a whole lot of stuff happening as well. So especially at the state level, there's some really quite progressive states who are really deploying things quite rapidly, like Georgia Department of Transport had a ribbon-cutting ceremony just a month or so ago announcing they're going to be deploying 1,600 roadside units through Georgia. So, it definitely, we've been in this industry for more than a decade. It's always been frustratingly slow, but I got to say, I feel quite positive at the moment because it really does feel like the market is at a tipping point.
Yeah, that's great to hear. I know what you're saying. I've been, again, not involved anymore myself for many, many years, but always sort of followed it. And I always felt the same thing. I always felt like we're there, and then it kind of tampered off again. But I do agree with you. Lately, when I read and see and talk to people like you, I get encouraged that we're finally getting there. So maybe let's use the same theme of who's leading, who's following. And I kind of said, you said they're all sort of all on the same page, maybe with Europe a little bit ahead. When we're talking about applications, specific applications, and I know we've talked about connected vehicle, but that's a very generic, very broad term. What are some of the coolest things that you have seen people use with, again, cellular V2X or DSRC-based V2X, doesn't matter, that you have seen as we talk here about reimagining mobility? Give us a glimpse of what you have seen that maybe in a few years becomes the standard and is really rolled out into vehicles. What's some of the coolest stuff that you've seen that people have done with this ability of allowing cars to communicate with cars to communicate with infrastructure? And again, we're talking here on low latency, so not something that a car that's connected with a 5G connection can send data up to the cloud and get it back again, but really what the advantages of V2X really is intended to do. What have you seen?
Yeah, so we see, obviously, the industry talks about like things like day one applications and day two applications. So the day one applications are the ones that get deployed today, and they're a little bit, I wouldn't necessarily call them exciting, but they are very useful. So some of the big deployments are like roadwork warnings, just getting, as you're approaching a road, a roadwork site, you would get warnings about that. You would get end of queue warnings if there's a traffic jam on the freeway, for example. You would get this warning that, hey, the traffic is actually stationary ahead, things like that. So useful things, but not necessarily whiz bang kind of things. And then we move into day two applications. Then it gets really sort of quite funky there as well, because now we're talking about how to aid autonomous vehicles in how they drive and so on. All those same day one applications, but now they're not warnings to the drivers. They're information flowing to autonomous control system. But you also start to see things like cooperative perception. I think that's one of the coolest thing we see. I described that earlier, where it's basically you're sharing sensor information between vehicles, or even between vehicles and roadside. So we actually did a trial with the University of Sydney where we had a roadside unit which included LiDAR and radar and so on, and then we had these little autonomous vehicles which are driving around that who had no sensors whatsoever, and so they were perceiving the environment solely through roadside infrastructure.
Roadside, yeah.
That shows a real value, and that also those sort of applications really. A hot topic now is vulnerable road users. How can we improve the safety of pedestrians and cyclists and to a certain extent also motorcycle riders? And that's a lot of that is big there. We did a trial with Intel in Arizona last year, where again it was roadside units with cameras detecting pedestrians and then turning that into a infrastructure to vehicle message to let the vehicles approaching the intersection be more aware of the pedestrians that were crossing.
Very interesting. So some of those roadside systems that actually can reduce the number of sensors you need on a per vehicle basis, because you get the information in a real-time basis from the roadside equipment then, right? Especially maybe in shipping yards, in I don't know, in confined areas, maybe in a plant or something like that. Very interesting, yeah.
Yeah, indeed, and it also has obviously at the moment autonomous vehicles are high-end vehicles, and so the price of the sensor suites not as great, But you can imagine a future. Well, what about autonomous low-end vehicles where you a lot more price constraints or cost constraints, and there, sharing sensor data can really, lower the cost of the sensor suite, and also, extend the horizon of your sensors, by basically, talking to all the vehicles and infrastructure around you.
Very interesting. Yeah, very interesting. Two more questions for you. One, what do you see happening in the mobility space? Let's talk anything on the ground. So from two-wheelers all the way to multi-axle heavy-duty trucks, on-road and off-road. What do you see happening in the next, let's say, 5 years, Paul? Anything, either in your industry or just generally speaking, that excites you personally?
I guess we're seeing, in terms of mobility, micro-mobility has become a hot topic. We're seeing, because we're now getting e-bikes out there and e-scooters, and they've got power and they've got electronics. So we are starting to see some activity around having connected bicycles and connected scooters, and that's going to be a big boon, especially for those vulnerable road users. And then for larger vehicles, we're obviously seeing platooning activity. And that's still an ongoing topic about having those vehicles platooning. There's even a big project here in Australia, in Western Australia, where it's on a private road with mining vehicle or carrying trucks, and these are platoons of road. So in Australia, you have road trains where they just link together multiple trailers, but now they're platooning those road trains together, so they can have one driver and move a lot of stuff. It's almost like turning these roadways into railways.
Interesting. Well, now I have one more question on top of my last question, because we just got on the topic of platooning.
Yeah.
Also something I used to work myself, so you piqued my interest. I haven't heard much about platooning, at least not in the US and even in Europe, over the last, let's say, almost 3 plus maybe 5 years. Now you're bringing it up in Australia. I actually knew about this project you're referring to because I read about that. So how big is platooning really still on a global basis? Still a big topic specifically for heavy-duty truck, for goods deliveries, or not anymore?
I think still a hot topic. I think there's been some interesting challenges that have arisen. So one of the prime focuses of platooning originally was to reduce fuel consumption by having the vehicles traveling distances, but that started to become, the challenge there is, especially in different brands of vehicles who have got different brake systems. They're very effective brake systems, but if you've got the platoon in an emergency braking situation, those vehicles have to be coming to a halt in lockstep, and that becomes quite a challenge. You have to do sort of some closed loop feedback to make that happen. Whereas you get the platoons where the whole goal is to have them more spread apart, and such as that example I mentioned here in Australia, that becomes less of an issue because they may be following at 100 yards distance instead of 10 yards distance.
All right. Very interesting. Perfect. So now my last question to you, Paul. What is the next vehicle you're going to buy and why?
For me, it's going to be an electric vehicle. I've still got an internal combustion vehicle. I think it's just it makes a lot of sense now. They're quite commonplace. Price is a bit more reasonable now when they first came out. So I think that's for me the next vehicle. I'd love to have a connected vehicle, but it's not really available here in Australia yet. So, but if that just for my personal interest, that'd be a factor as well if it was available to me.
And what's more important, the range or the electronics and the technology that's in the vehicle?
I think the technology and so on. So my daily commute is like 20 minutes. So I don't, from that range perspective, going away, maybe every 3 months I might go on a trip. And so I just have to plan that around charging stations. So I guess I don't have any range anxiety because of, the majority of my use is just it's not an issue.
Very good. Paul, thank you so much for your insight. Very interesting. Brings a lot of great memories back. I know you and I worked in the past together. Best of luck to you guys. Sounds like really things have progressed. It's fantastic to hear. And thank you so much for sharing your views and your perspective on how you, together with many other in the industry, are help reimagine mobility. Thank you so much, Paul.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.